All right, this is AP Calculus, lesson 4-4. We are talking about mean value theorem applications. So, what is the mean value theorem? We talked about this in Unit 1. Do we remember what it is? Yeah, it deals with slope.
Closed points and continuous.
Yeah, it needs closed points and continuous, but the main thing that we need is it needs to be what? Starts with a D. Differentiable, perfect. Do you remember the definition of what the mean value theorem states? F prime of C is equal to what?
F of 1 minus F of 2 over 2 minus...
Yeah, you basically have it. Let me write it in a slightly different form. And that is, instead of writing F of 2, I'm going to write F of B minus F of A all over B minus A. That is the theorem. This is something that needs to be locked away in our memories.
I remember that.
You remember that?
Yeah.
All right. So there's another way of writing this, and this is something that you can remember in addition to this to help you think of this, and that is this. The tangent, because f prime of c, that is the tangent, is equal to, and this here is called the secant. Do you remember the difference between tangent and secant?
Okay. The tangent like barely touches it and the secant like goes through it, kind of?
Yeah, that's a good way to think about it. And maybe I should have written secant in black so it matches my graph. Maybe I should have written this entire equation in black. Because the tangent happens to be this red line. It touches at one point. It just skims the edge. So that was the tangent. And the secant, as Rosalie said, it goes through the function more. It hits the function at least twice, sometimes more than once, or sometimes more than 2 times. In fact, the tangent, technically, it does intersect this section again. But within this restricted area, it only hits the function once. You can clearly see that the secant hits it twice. So this is called the secant. So this is something that we're going to be doing on the homework over and over again. You're going to write this probably 7 times tonight. Actually, how many questions do we have on our homework? We have 8 questions. You're going to be writing this theorem at least 8 times tonight.
Oh my god.
So hopefully it'll be locked into our memory tonight or in class. We're going to do most of it in class. All right, so
I'm gonna be scaring children.
here we go. By the way, this is where we are in our unit guide. We're on lesson 4-4, and we are almost halfway through the unit. Still on standard J.
I don't like standard J.
Okay, so I want to give you guys an example. So let's do this in black. Okay, so a bit of writing here. Here we go. Here's your question. If C, some number, is the number that satisfies the conditions of the mean value theorem, so it satisfies the conditions. Okay, I can spell conditions. Conditions of the mean value theorem, abbreviate MVT, of the mean value theorem for, and then here's my function. F of x is equal to x cubed minus x squared. And I'm going to tell you on what interval. On this interval, and give yourself some room, x is going to be between and including 0 and 1. Then, almost done here with the question, C equals what? So this is a very common type of question about mean value theorem that you might encounter on the AP test, and I'm going to show us how to solve it. Like always, the first thing that we're going to do is try to analyze this problem. So the main thing here is we're going to try to find C. Once we find C, it even says it down here, once we find C, we're done. Whenever I see the words mean value theorem, this is immediately what you need to think of. So in a word problem, mean value theorem, automatically, this guy means use the formula. Automatically write it. So maybe I should have had the arrow come down here a little bit more.
Like if they took it in slope, like their main figure.
Oh, I saw the word MVT, mean value theorem. That means I'm going to say tangent is equal to the secant. And to be more specific, it's the slope of the tangent is equal to the slope of the secant. And that means f prime is going to equal, do you guys remember the formula already without looking at your notes above
F
this
of
area?
B minus F of A over B minus A.
All over b minus a. Well done.
I remember that.
Okay. And now we have to analyze the problem, what are a and b? And it happens to be in this interval, a and b. What would you take a guess for a and b?
0, 1.
Yeah, a is 0 and b is 1. In a mean value problem, they will always, and I repeat, they will always give you an interval because they need to give you an a and a b for your formula.
Okay.
All right, so now we just need to plug in and find what c is equal to.
Chocolate gave me a really nasty taste in my mouth.
Wait, so just F prime equals that whole thing?
Right. Well, it's f prime of c, I should say.
And
We need to find what c is equal to. What value goes in here? So here we go. We're going to solve.
no, here we go.
So I have my f of x. I'm going to come over here to the left so I have more room. F of x. That was given to me to be x cubed minus x squared. So how are we going to get some f prime? Remember, we need an f prime of some value. How do I get f prime?
Take the derivative.
Take the derivative. The derivative is what?
Yeah, the square minus 2x.
Minus 2x. Perfect. And that's still being set equal to my f of b minus my f of a all over b minus a. Okay. Give you a little bit of time to digest. What did we just do?
So you set the tangent equal to the secant.
Yep, we set the tangent line, the derivative, equal to the secant.
You know that the tangent is f of x.
F prime of x.
Oh, okay.
So then what is F
Can we
of
write that
X?
on the
F of x is the function.
Tangent equals.
So this f prime is now the tangent.
equals derivative of function.
Yes.
And then the secant equals the formula.
Yes.
So now you plug in.
Exactly.
Wait, what is it? Wait, secant equals.
So f of b, what was b? B was 1.
And secant equals. What is secant?
What was a?
The formula f of b
zero.
minus f of a.
1 and 0. So what is f of 1? That's the new question.
You plug it into that formula.
Yeah, what is f of 1?
1, no, 0.
All right, I'm going to make sure that all the other girls catch up too. F of 1 is something cubed minus something squared. I'm just using our formula that they gave us in the problem, and I'm plugging in 1 to find f of 1, because this 1 was plugged in here. I'm finding f of 1, so I'm plugging in that 1 here and here. And Joy correctly stated that f of 1 is equal to 0.
So, because F of 1 equals 1 cubed minus 1 squared. Okay.
Yep.
God, this is kind of like review almost.
That's good. That makes me happy that this is a review. That means we remember it pretty well. So f of a. F of a, that means f of 0. F of 0. That's going to be 0 cubed minus 0 squared. And again, f of 0 is 0. So plugging back into our formula. Let me give myself some more room down here. Come on, erase, erase. So now I have 3x squared minus 2x is equal to what? F of b
Zero.
was 0 minus f of a, which is 0. 0 minus 0 divided by, what was b minus a?
1.
1. This is 0 divided by 1,
0.
which is 0. Now I need to solve for my x. And I guess I need to be careful here because I should really be plugging in c here. So I should have caught this before, but this should be f prime of c is equal to 3c squared minus 2c. I know it's basically the same thing. You're still solving the same problem, but it would be better if we could change these to c's instead of x's.
All of them?
Yes.
Why don't they just give you one, like, thing? It's kind of annoying.
Sorry about that. So
I thought it was just a problem you pull.
Oh god. Poor Mr. C.
now we,
So how come it's f prime of c?
because our definition here says f prime of c, so now we're plugging in c for the value of x. So all of this x's change to c's. All right, so let's go ahead and factor this problem. What can I factor out? What's the greatest common factor?
C.
C times what goes inside?
3c minus 2.
Okay. Therefore, c is equal to what?
Could be equal to
0.
0. Or
2.
2/3.
0 or
2/3.
2/3.
Oh, right. This lead keeps breaking on me so bad.
do you always want to get it set equal to 0 like that?
Well, it's going to be
It was like
it's,
4.
it's not equal to 0. It just happened to be 0 from the numbers that we plugged into our equation over here.
But
Sometimes
do you
it-
always want to get 2 answers?
you might get 2 answers. You might get 1 answer.
Okay.
Okay, here. So I think we have to be careful here. I don't think 0 is an answer. Because remember, we need to take f prime of, we're taking the derivative of the function. This is an endpoint. Do we see that?
Yeah.
What do we know about endpoints in terms of their differentiability?
B&E or
Endpoints don't have a slope.
Endpoints don't really have a slope, yeah. So we're not actually sure about 0 because we took the derivative to find 0. So I think because this is an endpoint, we're only going to be saying c is equal to 2/3. Yeah, so go ahead and write in our notes
Okay.
this 0 endpoint.
So it does not exist?
So the idea here is if we plugged in 0 for c, f prime of 0, you can't do f prime of 0. You can't take the derivative of 0 because 0 is an endpoint. So the correct answer here is c is only equal to 2/3.
Are there any other numbers that aren't going to... It's just going to be 0 that doesn't work, right?
0 or 1 if we found 1 to be a number because that's also an endpoint. Or any number outside of the interval. What if we found 2 to be an answer? Well, that doesn't work because it's only defined between 0 and 1.
So it's... Oh, that makes sense.
So I guess the last step, and we'll write this in the notes on the side. Last step. Verify. Answer is in the given interval.
And then also 0 and 1 are endpoints, they don't count.
Yeah, and then I guess for that one, be careful of endpoints. No endpoints. All right, so that's all I have for us today. So let's go through that once again. We had a problem. where we're trying to find some c, and you're almost always going to be finding some c that satisfies the mean value theorem, the first thing you do is write out the formula for mean value theorem, this guy. From there, we had to find the left-hand side and the right-hand side. Just plug it in. We had to find f prime from f. We found f prime. We plugged in c. Good on the left-hand side. The right-hand side, we needed to plug in a and b from our endpoints to find b and a. We plugged into the function twice, and we found that that was actually 0/2. Sometimes you'll have a number here, and this will be a quadratic that you can factor. And then we set both sides equal to each other. We solved for c, and then got our answer. Are there questions?
No.
All right, that concludes the notes. Do we want to say goodbye to Sophia?
Bye,
Bye,